Hello everyone, welcome to Maths YouTube channel. Today in circles chapter, let's do some 2-mark questions. The first one is, O is the center of the circle. Prove that at least one pair of opposite sides AEDB of this quadrilateral is parallel. That is what I am supposed to prove. Which are the opposite sides? AB and ED and AE and BC, right? AE and BD. So these are the opposite sides. So any one pair I am supposed to prove that they are parallel. How can I prove that two lines are parallel? There are three conditions. One is if you have alternate angles and they are equal, right? One is corresponding angles and they are equal. And the third one is if you have co-interior angles which add up to 180 degree, I can prove that they are parallel lines, right? Here you can see that this line, let me take this as M and this as N. These are tangents to this circle, right? Then can I say that angle OED, this line, this angle is 90 degree because radius is perpendicular to the tangent. Similarly, OAB will also be 90 degree because again radius is perpendicular to the tangent, right? So I have got two angles which are equal to 90 degree. Okay. Now let me explore other angles also. Okay. If angle B is x degree, if angle B is x degree, then what will be the measure of angle D? Because we know that sum of all the angles of a quadrilateral is 360 degree. I already have 180 spent, then this is x degree, then how much will this be? 180 minus x. This will be 180 minus x. If that is 180 minus x, then what will this angle be? That is angle BD, let's say this is F, then what is angle BDF? It will be x degree only because these two form a linear pair. Now you can observe a Z here that starts from A. You can observe a Z. Z is for alternate angles, right? So you can observe that these alternate angles are equal. So since alternate angles are equal, I can say that AB is parallel to ED. Since angle ABD is equal to angle BDE, so BDF, I can say that AB is parallel to ED. Done? Okay. Now the second one. For this you will have to go back to 9th standard also. But let's look at the question first. O is the center of the circle. Find angle AQB. Okay. This is the angle we are supposed to find. Alright. They have given this PA and PB are tangents to the circle and this is 75 degrees. Angle APB. Then what will be the measure of this angle? PBO, it will be 90 degree because again here you can see the radius perpendicular to the tangent. Similarly, the radius here is perpendicular to the tangent, so this will also be 90 degree. Now if I consider this quadrilateral PAOB, this quadrilateral, sum of all the angles will be 360 degree. Already this is 180, so this will also add up to 180 degree. If this is 75, what will be the measure of angle AOB? Angle AOB will be 180 minus 75, that is 105 degree. Okay, so this is 105 degree. If you can observe, if I take AB as the arc of the circle, you can see that this arc is making AOB at the center of the circle and AQB at the circumference of the circle. And we know a relation between these two. What is that? Angle AQB is equal to half the angle at the center, that is angle AOB. And how much is that? It is 105. So if I substitute, I am going to get 105 divided by 2, which is 52.5 degree. Now the third problem is, O is the center of the circle, NQ is a tangent, find angle OQN. So I am supposed to find this angle. You can observe that this angle is part of the triangle OQN, right? Also, ON is the radius and QN is the tangent. Then what will be the angle formed here? It will be 90 degree. So if I find out what is the measure of angle NOQ, it's easy for me to find what is angle Q. If you observe this NP, arc NP, you can see that it is creating two angles, that it is subtending two angles, one at the center and one at the circumference. And we already know from the previous problem that this one angle at the center will be double the angle at any part of the circumference. So since this is 25, this will be double the 25, right? That is 25 into 2, which is 50 degree. So if this is 50 degree and 90 degree, what is the angle of left out angle? It will be 40 degree, right? So that is angle OQN. Done. Now let's go to the fourth problem. A, B and C are sides of a right triangle where C is the hypotenuse. A circle of radius R touches the sides of triangle. Prove that R is equal to A plus B minus C by 2. So let me draw a circle first. So we know that the radius of this circle is R, and there is a right triangle which is touching this circle. Okay. So this is the right angle triangle. And we know that if I take A, B, C as the vertices of the right angle triangle, and wherever it is touching as P, Q and R. If I take this, we know that AC is the hypotenuse and the measure of AC is given as C. So the whole thing here is C. AC is equal to C. If I take AB as A and BC as B, let's say. Suppose this is the center of the circle and I join O to P, O to Q. Okay, that is the point of contacts. I know that OP is R and OQ is also R, radius of the circle. Observe that this angle OPB will be 90 degree. Similarly, OQB will also be 90 degree, right? So these two angles will also be 90 degree and all sides will be equal. So if OP is R and OQ is R, what will be the measure of BQ? It will be R and PB will also be R. Also notice that B is the external point from where you have two tangents BQ and BP. So obviously they have to be equal, R and R. Similarly, if I take A as the external point, observe that there are two tangents AP and AQ. Sorry, AR, right? AP and AR. Obviously these two will be equal, but what is the measure? If part of AB is R and we know that the entire thing is A, okay, I can take it as A, then what will be the remaining part? AP, it will be A minus R. If AP is A minus R, then AR will obviously be A minus R. Similarly, if I take the external point C here, I have two tangents CQ and CR. I know that B, the entire BC is B units. Okay, then if this is R, what will be the measure of QC? It will be B minus R. If QC is B minus R, what will be the measure of CR? Equal to B minus R. Okay, but we know something about AC. The total length is equal to C. So AC, I can split it as AR plus RC, right? And this AC is equal to C and is equal to AR is A minus R plus B minus R. Done. Now you can retain R on one side and shift everything to the other side. So let me bring this minus R and minus R to one side. So that will give me 2R. So 2R is equal to A plus B minus C. Then R will be equal to A plus B minus C by 2. This is what you had to prove. Done. In circles, if you don't get 2-marker questions, then a 3-marker question is a possibility. So let's look at some sample problems now. The first one is like this. Prove that a parallelogram circumscribing a circle is a rhombus. So what is the meaning of this? If I have a circle and there's a parallelogram circumscribing it, meaning it is touching the circle, the sides are touching the circle like this. Okay, so this is a parallelogram. I am supposed to prove that this is a rhombus. So whenever I am supposed to prove that a quadrilateral is a rhombus, I should prove that all sides are equal. So let me first name this parallelogram PQ, R, S, and the points where it is meeting as A, B, C and D. Okay, I know only one thing about this, that PQ is equal to SR and PS is equal to QR because opposite sides are equal in a parallelogram. Suppose I take this P as the external point, I have two tangents from here, PA and PB, and both will be equal in length. So let me consider that as X for now. Again, if I take Q as the external point, I have QB and QC as the external tangents from the external point. They will also be equal. Let me take it as Y. Okay. Now let me consider R as the external point. Then RD and RC will be the tangents from the external point. Let me consider that as Z. Now I know PQ value is X plus Y. So obviously SR will also be X plus Y. So the total length is X plus Y and part of it is Z. Then what will be the left out value SD? It will be X plus Y minus Z. Now since S is an external point and from there I have two tangents SD and SA and already SD is X plus Y minus Z, then SA will be same X plus Y minus Z. Okay, so I know now this is X plus Y minus Z and this is X. I also know that PS is equal to QR because they are again opposite sides of a parallelogram. So let me equate these two. What will I get? X plus Y minus Z, that is this part, plus X will be equal to Y plus Z. Okay, so now I can cancel Y and Y. So I am left with 2X is equal to 2Z. Then X will be equal to Z. So let me replace Z with X here. So in place of Z, I am writing X. Here in place of Z, if I write X, X and Z gets cancelled and I am left with Y. Similarly, AS will also be Y. If you observe, all sides measurement is X plus Y, X plus Y, X plus Y and X plus Y. Since all sides are equal, I can say that this is a rhombus. That's it. Now let's go to the second problem. Shown below is a circle with center O. Tangents are drawn at A and C. If OA is perpendicular to OC, then show that OABC is a square. Now, if you have to prove that any quadrilateral is a square, there are two things that you have to satisfy. One is all angles should be equal to 90 degree. And the second one is all sides should be equal. So both conditions should be satisfied. Since at A and C you have tangents, I can say that OC and OA are perpendicular to those tangents. So angle OAB and angle OCB both will be 90 degree. Also they have given that OA is perpendicular to OC. That means here OA and OC, they are perpendicular to each other. So this angle will also be 90 degree. If three angles are 90 degree, automatically the fourth angle will be 90 degrees in a quadrilateral. So I have proven the first one that all angles are equal to 90 degree. Now you observe OC, if all angles are equal, I can also call this as a rectangle, right? So OC is equal to OA because they are radius. Also CB is equal to AB because they are tangents from the external point. Now since this is a parallelogram or rectangle, since I know OA is equal to OC and AB is equal to BC. This is the information I know because they are radius and this is tangents from the external point. But since all angles are 90 degree, opposite sides will be equal. What is the meaning of that? OA will be equal to BC, right? But what is OA equal to? It is equal to OC and BC is equal to AB. So I have proven that all sides are also equal. So since all angles are equal to 90 degree and all sides are also equal, I can say that this is a square.